The next interface we're going to talk about is the collection interface, which represents an object that acts as a collection or a container for other objects. What are the operations that we need to work with a collection? We should be able to add an object to this collection. We should be able to remove an existing object. We should be able to check for the existence of an object and so on. These are the operations that the collection interface declares. Here on the documentation, you can see that the collection interface is also a generic interface because here we have a generic type parameter. But instead of T, we have E, which is short for element. That is a common convention for declaring interfaces or classes that have a collection semantic because a collection can have multiple elements, okay? Now, over here, you can see that this interface extends the iterable interface. So every collection is also iterable. And that means we can use a for each loop to iterate over all collections in Java. Now over here, you can see various classes that implement this interface. As you can see, there are over 20 implementations of this interface. Most of the time, like 90% of the time, you only need to use the ArrayList class. These other implementations are for special purposes, and we're not going to cover them in this course. You can learn about them on your own. I just want to give you a strong foundation. So back to our project, I'm going to add a new package called collections. We're going to write all the code in this section in this package. I'm going to add a new class called collections demo. In this class, we're going to have a public static method called show. This is where I'm going to show you various operations in the collection interface. If you download the source code that I've included at the beginning of this course, you can see all examples in this class. But while I'm recording this video, I'm going to delete some of these examples to keep the screen clean and easy to read. Now, back in the main class, we're going to call collections demo.show. Now, here I'm going to declare a variable of type collection of string. Let's import this type. So that is an interface. We call this variable collection. Now here we should set this to a new instance of ArrayList because this is one of the classes that implements this interface. Now let's add a few items to this collection. So collection.add, we can add a string like A, then B, and then C. Because this collection is iterable, we can use a for each loop here. So for item in collection, we can print each item. So we get ABC. We can also print the collection as a whole. So print collection. Now, what if you want to add multiple items in one go instead of calling the add method 3 times? Well, here we have another class called collections. That is a utility class declared in the java.util package. This class has a method called addAll. The first parameter of this method is the collection that we want to modify. So we pass our collection over here. Now look at the second argument. Here we can see the list of parameters by pressing Command and P on Mac or Control and P on Windows. If the shortcut doesn't work for you, you can find it under View, Parameter Info. Okay. So look at the second parameter, a string ... When you see ... that means you can pass a variable number of arguments. You can pass 0 or more strings. So here we can pass A, and then B, and then C. So instead of calling the add method 3 times, we're passing multiple arguments to this method. Now, if we run our program, we get the same result as before. Another useful method is the size method that returns the size of a collection. So here we have 3 items. We also have a method for removing an object from a collection. So we can call collection.remove A, and then we can print the collection. So A is gone. We can also remove all items by calling the clear method. Now the collection is empty. We can verify that by calling the isEmpty method. So it returns true. If you want to check for the existence of an item, you can call the contains method. So we want to see if this collection contains an A. So it contains A, and then we can print contains A. We get true. There are times you want to convert a collection to a regular array. So here we call collection.toArray. As you can see, this method has 3 forms or 3 overloads. If you don't pass any arguments here, this will return an object array. So we can store it in an object array. So every item in this array is going to be an instance of the object class. That means if we get the first item and use the dot operator, we don't see any of the string methods. If that's what you need, then you need to convert this collection to a string array instead of an object array. That's very easy. We call collection.toArray. We're going to use this form, this overload that takes a T array. So if we pass a new string array here, now how many items do we have in this collection? 1, 2, 3. So we pass a string array over here, and this will return a string array. Also, we don't really have to specify the size here. We could simply pass 0, and that is a common convention because you don't want to worry about counting the number of items in your collection. You can simply pass an empty array, and this method would automatically create an array with enough capacity to hold all these items. Okay? Now, if we get the first item, we can access all the string methods. For example, we can convert the string to the lowercase or uppercase and so on. And by the way, we can use var here, just as usual. Now, some people don't like var. They argue that we cannot see the type of this object, but that is not right. So if you put the caret over here and then go to View, Quick Documentation, the shortcut is F1, you can easily see that this is an object array. Or if you put the caret over here, and one more time, press F1, we can see that this is a string array. So I personally prefer var because it makes our code cleaner. So this is how we can use the toArray methods. Now, there are times you want to compare two collections for equality. So I'm going to create another collection of type string. Let's call it other and set it to a new array list. Now, what would happen if we use var over here? Then the type of this variable is going to be the ArrayList class, not the collection interface. So it's going to include the additional methods that are declared in the ArrayList class. Now, as I explained in the second part of this series, we should program against interfaces. This will make our applications more flexible and loosely coupled. So I'm going to revert this back to collection of string. Now, I want to add every object that we have in this collection in our second collection. So we type other that add all. Now look at the type of this parameter. It's collection of unknown extends string. So we have a wildcard again. That means we can pass a collection of string or any type that extends the collection of string. So I'm going to pass our first collection. Now, you want to check to see if these two collections are equal. So I'm going to do a print statement here. What do you think is the result of this expression? Collection equals other. Are we going to get true or false? We're going to get false because these are two different objects in memory. Look, here we have two new operations. So these are going to be different objects in memory. And this equality operator compares these objects by their references or their addresses in memory. Now, if you want to check to see if two collections have the exact same content, you should use the equals method. So print collection equals other. Take a look. So we get false as a result of evaluating this expression because these are two different objects in memory, but we get true because these two collections have the exact same content. So this was all about the collection interface. Once again, don't worry about memorizing any of these. All you need to take away from this video is the kind of operations that are provided by the collection interface. We can add an object, we can remove an object, we can check to see if an object exists, and so on. Don't worry about memorizing. You can always look at these operations on the documentation. Next, we're going to look at the list interface.